I also wanted to give you another problem of how to do factoring when it's 4 terms, just so that you have a different, refreshing your skills when we had 2 terms, 3 terms, and now 4 terms. Again, the directions still say simplify the rational expression. So we're going to try to figure out how can we break this top thing as factors, how do we break down the bottom by factors. Notice right now we have a trinomial and 4 terms and no multiplication symbol. So how do we break this down? Factor out the top. So when we have the top, notice it's p squared minus 4p plus 3. There's no GCF. You can see because it's 1, 2, 3 terms, nothing in front here, so I'm going to do shortcut. When I do shortcut, setup, P and P, signs, we know this is the same type, they have to be the same negatives. Next, convo list, 1 and 3. Next, add the list, we get a 4. See what matches, perfect, and then placement. Since they're both the same signs, it didn't matter where the 1 and the 3 went. So this can be broken down as p minus 1 and p minus 3. By factoring it out, we got our multiplication symbols. Remember, parentheses act as multiplication symbols. So this is one factor, this is your second factor. Now let's break out this second guy. P squared minus 3p plus 12p minus 36. 1, 2, 3, 4 terms. Now 4 terms, you have to do this totally different than what we've been doing. When it's 4 terms, we told you the only type of factoring that we know how to do is to see if there's a GCF, which there isn't, and then to do grouping. So grouping is where we do parentheses around the first 2 terms, parentheses around the last 2 terms. In the first 2 terms, you take out a GCF, which is p, so you're left with p minus 3. And in the second, you can take out a 12. And since it starts as a plus, make sure it's a plus 12. Then you're left with p minus 3. Because these match identically, we're going to take them out as just one set. The GCF here and here will make up the other set of parentheses. So the bottom breaks down as p minus 3 and p plus 12. So we factor out the top, and we got these 2 parentheses. We factor out the bottom, we got these 2 parentheses. So we have 1, 2, 3, 4 factors. Look to see if there's any factors that match. If you have matching factors, you can only cancel out if 1 on top matches 1 on the bottom. If this was also a p minus 3, these 2 cannot cancel out with each other. It can only be 1 on top with 1 on the bottom. So here, they cancel out. So I'm left with p minus 1 over p plus 12. Do not cancel out p with p. The reason why is because we got rid of the multiplication symbols. This is a subtraction. This is addition. They act like super glue. When they act like super glue, you cannot cancel out pieces. Okay, remember I said you can only cancel out matching binomials. These binomials don't match. Maybe pieces do, but that doesn't count. You can only do pieces of GCFs, never pieces of binomials. This would be our final answer. Even if I had p minus 1 over p that's in a binomial and p that's a monomial can't cancel out. These are not identical, okay? For p minus 1 to cancel out, you would have to have a p minus 1 at the bottom. So just remember, if you just have a p on top and a p on the bottom, but they're in binomials, you cannot cancel them out. You can only cancel out monomial p with monomial p, not binomial p with binomial p. So these binomials cancel out, these don't, they don't match. This is our final answer, p minus 1 over p plus 12.